This is lesson 6, activity 2, info gap, transformation information. So info gap, because students work in pairs and one student has a data card and the other student has an image. So for example, this image. And so they have a gap in their information. They have to ask questions about how to move this image through a sequence of transformations based on this data card. And so they're going to ask some questions to find out how to move the image. They're going to make that move, and they're going to end up the blue shape. The blue image is going to move to the green image. So how do you get from here, the blue image, to here, the green image? So you have to go through a series of questions and make those transformations to do that. The second one, here's a data card for the second transformation. So there's 2 data cards and 2 images. And here's the image that goes with that data card. And this image goes through a sequence of transformations and ends up here. And actually this one you can see there's a rotation. You can see that, and it's probably a 90-degree rotation. It looks like this goes 90 degrees and ends up down here. So you can begin to ask questions about what information do you need if you recognize that it's a rotation. Actually, you don't know this answer yet, but you start to realize, oh, you're talking about a rotation. Well, to help you along, here's a series of questions that you can ask. Now, some words that trigger those questions. And I mixed them up so that you can't just go down each row and ask the question in a non-thinking way. You need to kind of look at these and say, well, first of all, I have to find out what kind of transformations there are. So here's that word transformation. You know about 3 transformations. You know about rotations, you know about reflections, and you know about translations. And once you identify that, for example, it's a rotation, what information do you need to ask about a rotation? So the idea is to be systematic and go through this in a logical way. All right, I found out it's a rotation. So what do I need to ask about a rotation? Well, I need to ask about the direction of rotation. I need to ask about an angle of rotation. And I need to ask about a center of rotation. What if I identify that's a reflection? Well, I need to ask what the line of reflection is. And how about a translation? How many units does the image move along the y-axis? And how many units does the image move along the x-axis? So try to be systematic. Don't just in a non-thinking way go through these words, but try to think about what information you need to know based on what transformation you have identified. And there is an order to the transformations. Does that order make a difference? We'll talk about that a little bit later. So this is the first image, and what happens first is this image gets translated, and it gets translated up 2 units and to the right 3 units. So you move it up 2 to the right 3, and it ends up right there. And then this image gets reflected. So if A is going to get reflected all the way down here, notice that A is farther away from the line of reflection, so it's going to end up farther away down here from that same line of reflection. C is going to end up here, and it's going to end up actually being closer to the line of reflection. And D and B are going to end up down here, and they're going to end up pretty close to the line of reflection. So first of all, you have to, it's a good idea to just go through the showing that you form a prism from a translation. Sorry about that. So here's one base, and so a prism is formed by the translating a copy of the base. So here's the purple base, and this red base is a translated copy of this purple base. And then the sides are connected by parallelograms. And if they're right angles, they are connected by rectangles. Well, those are almost rectangles. Maybe not quite. But this just shows you that it's a prism. This is actually a quadrilateral prism. There's 4 sides to it. And it's just good to demonstrate that you get a prism after the translation. So now let's look at the reflection. this image gets reflected over the x-axis, so A prime ends up all the way down here where A double prime is, and C prime ends up here where C double prime is. So notice, I just want you to see that A is farther away from the x-axis, so on the other side it ends up an equal distance farther away from the x-axis on the other side. C is closer. Now, what if you did the reflection first? So here's the reflection first. In this case, notice that A is closer to the x-axis because A starts out closer. A is right here, and it gets reflected to right here. C is farther away, so now C ends up farther away from the x-axis, and D and B remain right on the x-axis. And so when we do this translation, this image is going to end up even farther. It's going to end up here somewhere, so it's going to end up in a different place. So if you change the order, that's going to change where the image ends up because you're using the same line of reflection in both cases. Yet you're moving where the image is and then reflecting it, but you're using the same line of reflection. So it ends up in a different place. So this gets translated up 2 units, to the right 2 units, and now it's way up here. Whereas before, the image ended up down here. When you did the translation first, and then the reflection, it reflected over this x-axis and ended up down here. When you reflected first, it just ended up basically reflecting over this x-axis, but pretty much remaining in the same spot. But then you translated it up, it moved way up here. So the order does make a difference. All right, so let's look at the second card in the second image. So this image has a rotation in it. It's a 90-degree rotation. So I'm going to go through. You now have 4 ways to look at rotations around the origin that are 90 degrees. So the first one is just to think about it, just to realize, gee, this is going to rotate 90 degrees to this point right here. And then you can prove that by connecting the 2 corresponding points and then drawing a line that's perpendicular through the center of rotation. Well, it better go through this origin because that is the center of rotation. And it does. So that's L prime is rotated 90 degrees. So what about M? So M, look at it, think about it. You can start to think that it's, I can draw a line from the origin up to here. So this is a rectangle. I'm drawing a diagonal, so I'm going to go over 1 unit, up 2 units. Up. So now you're starting to use that counting strategy. So now you just think about, oh, there has to be a line that goes from here, the origin, and it's going to end up about right here. So now you're reversing the order of the coordinates. So you're using a counting strategy. You're reversing the order of the coordinates. So here's the reasoning. So you think it ends up right there. So let's prove that by using the coordinates. So I'm going to change the order of the coordinates. So instead of -1, 2, it's going to be 2, -1. So I'm going to count over 1 unit and up 2 units and rotate this 90 degrees, count up 1 unit and over 2 units. But both of these values are positive. So count up 1 unit and count up 2 units. So you have to change the sign of that -1 to +1. So now you're using the coordinates to figure out where the 90-degree rotated point lands. And you can count. Count over 1 unit, up 2 units. Count up 1 unit, so I'm rotating 90 degrees. So notice you're switching, this is the x-axis, and now you're switching, counting that 1 unit to the y-axis. Well, that's what you've done here. You've switched this value and the x value to the y value, and you've changed the sign. Instead of counting in a negative direction, you're counting in a positive direction. So it all begins to make sense as you practice this. And count over 2 units, count up 2 units. So those are both the same signs, but it's just switching. This is the y value, and this now switches to the x value. So it becomes 2, 1. And then you can prove that by connecting the corresponding points and drawing a line that's perpendicular from the midpoint through the center of rotation. So the midpoint's about right there. And you can use Doceri to prove that to yourselves. It'll snap to that midpoint. And then you draw a line, and it better go through the center of rotation, which is the origin, and it does. So place M prime. So you place all of these points. So L prime we located here, M prime we located here, and you can do K and N on your own, and I would suggest that you do that. But you can almost just start to see it. So you count out 3 units, or I'm sorry, you count down 3 units to K, rotate 90 degrees, and you count out 3 units to K prime. Notice that they're on the axis, so you only have to count the units along the y-axis, and now count the units along the x-axis. But notice you're switching the order of the coordinates as you do that. So n ends up here at n prime, so count down 3 and 3 units in the direction of rotation. So now you're going to switch it to the x-axis and count 3 units this way to -3. Same sign, but now the sign changes to +3, counting up this way. So it's -3 units this way, +3 units this way. They're both 3, so it's kind of hard to tell the switching of the coordinates. And then finally, this image gets translated. 1 unit to the left and 3 units down. It ends up right there. And finally, I put this file, there's actually 3 files related to this, in a folder for you, and the link will be in the text that goes along with this video. So information gap, transformation, information.